In Rust you can use electricity for crafting, sorting and security, but most players don't know that electricity is capable of much more. With it I already made calculators and games, yet one goal always seemed out of range: creating a working computer. Other games have made them, Minecraft, Factorio, Terraria, but why not Rust? The time, effort and technical limits of the game are just too much to handle. But I knew it was possible. I just had to be the one crazy enough to do it. This project started 3 years ago. Every video I made so far was just leading up to this one. And the final program I want to run, it's something nobody would even attempt to do. To get there we need to create 5 programs first. Each will solve one particular task that is needed for the final one. We start with the easiest stretch goal. What's the simplest program a computer could run? There's one that every developer writes, no matter what language or machine they are learning on. Hello World. All it does is print those 2 words on the screen. As simple as it gets. Though that raises the immediate question, where do we actually print anything? The computer can't magically print on paper. Luckily, we already have a display. In a previous video I built a typewriter inside Rust, and its screen is exactly what we need here. Instead of typing on it by ourselves, we want the computer to do it for us. Starting out with just writing one singular character on the screen. For this, I have prepared these switches. Here we can specify what the computer should do. In our example, we want to output a letter. So we flip the output and set the right code for the letter. This uses the same logic from the typewriter to convert the letter code into the final character. When we start the program, one character is printed to the screen, and we can change the instruction to get a different character. This one gives us an A, and this one a 5. To print the full sentence Hello World, we obviously need more than one letter. So instead of one instruction, we line up 16. One for each character in the sequence. We start the program and the computer works through them one by one. Hello World! It works splendid! To change what we print, all we do is change the instructions to the letters we want. With a few changed switches, we can make it say all sorts of things. Rust, oil rig, roof camping noob, subscribe or I'll rate you. I've actually had this running all the way back in 2023. The Hello World program was the proof of concept. What comes after it gets way more interesting. Because a real computer doesn't just print text, it calculates, it takes input, it makes decisions, it remembers things. And we are gonna need all of that and more before we can run the final program I have in mind. Let's test whether the computer can calculate anything. For this we calculate the famous Fibonacci sequence. Here is how it works. Take 2 numbers, 0 and 1, add them together and you get 1. Now take the last 2 numbers again, 1 and 1, and add them, that's 2. We can keep the sequence going to get 3, 5, 8 and so on. The addition itself is easy enough. I can copy the circuit straight from the calculator I built previously. But we immediately run into a problem. The computer has nowhere to store the numbers. For this we introduce a component where the computer can store data. These are called registers. They can save a value and give it back later. Think of them as the computer's short-term memory. Let's go ahead and add 4 registers to the computer, which is just enough to keep track of the last 2 numbers in the sequence. Then we add together the numbers in those 2 registers and save the sum in the 3rd one. I went ahead and added a few more instructions to print out the number after each step and to loop back to repeat the calculation. With everything set, we start the program. After a short while, we see that we indeed get the correct numbers. Fibonacci was the very first program I ran on a computer in Rust. The machine looked completely different back then. No display, just binary counters blinking away. And if you're wondering why this video took so long, it was a whole journey to get there. Just getting the first 2 programs running took many weekends, because I didn't want this to be a novelty. I wanted to build something that could actually run a full program inside Rust. For the final program, I wanted to make Rust playable inside of Rust. People have been making jokes that I would do this one day, and the day has finally come. But to get there, the computer needed to be fast enough to be actually playable. And at this point, it wasn't even close. How bad the speed problem really was only became clear when I tried something bigger, which was the game Hangman. Hangman is simple enough on the surface. There's a secret word, you can't see what letters it has, just how many it has. Each round you guess 1 letter at a time. Showing the secret is something we can already do, but it requires something more the computer can't do at the moment. Take input from a player. Up until now, every program runs on its own. We press start and watch. Hangman actually needs to listen for an input, which means adding a new kind of instruction, one that pauses the program and waits for a key press. For the keyboard itself, I stripped down the one from the typewriter and built it into a much smaller version. When the light on the right stops blinking, it indicates that we need to input. When we press a letter, it gets printed on the screen and the check starts. The checking logic works like this. Take the guessed letter, compare it against each letter in the hidden word. If they are the same, reveal it. If not, move on. To save which letter we already have discovered, we write a value in a register for each. But since we only have 4 registers until now, I quadrupled them to 16. Just another one of the many updates I did along the way. Once that is done, the word is printed again, this time with any correct guessed letters revealed. Everything else still stays hidden behind an asterisk. Alright, let's play. See if you can guess the word. I'll try P. Interesting. Let's go with D. This time it actually found 2 spots for the letter. And how about an S? I think I've got it. It's splendid. The computer can now handle input, which crosses off another of the 5 requirements needed for the goal. But what if I told you the recording you just saw was sped up 40 times? One full check in Hangman takes 5 minutes, 15 seconds per single instruction. And Hangman is one of the smaller programs I would like to run. And the speed wasn't even the only problem. The sheer amount of components was making the game unplayable. It would lag and stutter, turning my electrical endeavor into a painful slideshow. I literally bought new PC parts just to keep up. And even that wasn't enough. Rust simply wasn't built for this. Like if you go over a certain amount of components in one part of the map, the server straight up crashes. Every fix revealed a new problem. Every hour spent felt like running an endless treadmill. And for the first time, I genuinely started to question whether any of this was actually possible. There will be times when you start doubting yourself, cause you see something nobody else does. You'll just have to keep pushing through. You have to keep believing. The solution was to go even bigger. It came to me when two fellow Restricians, Delindern and Lag Foundry, pointed towards something I had put to the side. Radio frequency components. These can transfer signals wirely at instant speed, so we can put down a broadcaster and set it to a frequency. And somewhere else on the map, we put down a receiver with the same frequency. Any change in the broadcaster will also be sent to the receiver. This would solve both big problems at once. I could have the signal near instantaneously wherever I need it, and I could spread all the big circuits far away from each other so they would not crash or lag the game. I took apart everything and rebuilt it. New display, new memory, new RAM, ROM, the computer itself, all of it. Don't ask me what I think about when I go to sleep. At the end, I was using more than 10,000 different frequencies to make all the parts connect. Then it suddenly all came together. What used to take 5 minutes to process a single hangman guess now takes 40 seconds at most. With the speed problem solved, it's time to push further. We already built addition for Fibonacci. Let's take it further and make a proper calculator. Addition, subtraction and multiplication. You type your calculation, the computer reads it and spits back the answer. The input side we can already handle, just like we did in Hangman. Type in 3 plus 5 and all 3 characters get stored in registers. The computer then needs to calculate and display the result. But here's a new problem. How does the computer know which operation to run? Right now it just executes the instructions in order, one after the other. It has no way to make a decision. So we introduce a comparison instruction. It tells the computer to compare 2 values. If they match, run one instruction. If not, run a different one. In our example, is the entered operation a plus sign? If yes, jump to the addition code. If no, check if it's minus instead. This might sound small, but it's actually a fundamental leap. The computer no longer just follows a script, it makes decisions. Type in your calculation and there's your answer. Addition, subtraction, multiplication, all working. The calculator is working fast thanks to the RF upgrade, though a new problem was creeping up with it. So far I've been describing instructions in plain English, but the computer doesn't understand English. It only understands one thing, ones and zeros. Every instruction is a specific combination of these zeros and ones. Now imagine writing a program like this with hundreds of instructions. That means flipping hundreds of switches by hand without a single mistake. One wrong digit and the whole thing could run incorrectly. And good luck finding where it went wrong. To solve this, I built a tool that generates the components automatically from a text file. I just write print H and the tool converts it automatically. Which means I essentially created my own programming language for a computer I built inside a game. Going back to Hello World, what used to require flipping switches one by one looks now like this. With the press of the button, my program generates a file for a building. That building we can then spawn on this server. And the best part is, because we use radio frequencies, I don't even need to connect the pasted building to anything. In hindsight, this automation saved me weeks of work. And we're gonna need every one of those weeks for what is still to come. Rust as a game always feels fresh because nothing is predictable. Every wipe is different, every encounter could go either way. That unpredictable core is what makes it so great. And if we want to have Rust in Rust, our computer needs randomness too. To test it, I built a fortune teller program. Ask a question, get an answer back. One question may be answered with yes, another with no, and the third one with
God, please, no! No!
The randomness itself already is built into Rust. These yellow blocks are called rand switches. Every time one receives a signal, there's a 50-50 chance it activates. We can use that to generate a random number and store it in a register. Then we use the same comparison logic from the calculator to check what number came up and pick the matching response. Simple in theory, let's see how it holds up. Will this video blow up? Maybe. Should you subscribe to Philieve? Yes. Okay, 5 programs working and a machine more capable than anything built before in Rust. All of this because I wanted to show that Rust electricity is truly capable of it. I want players to see and think, if that is possible, I could build something myself too. And if that's you, I've already made tutorials covering everything from basics all the way up to your first adder and even minigames. You can find these on my channel and on my Patreon. Now, about Rust in Rust. I'll have to be straight with you. A full graphical representation of Rust is not possible on this computer. Game requires real-time graphics, physics, models. What we have is a text display. But text is enough for something equally cool. Before graphical games existed, there were text adventures like Colossal Cave Adventure and Zor. You would read a description of where you are, type a command, and the world would respond. Press N to go north, interact with a button, pick up an item, fight an enemy. Pure imagination filling everything the screen couldn't show. These games ran on some of the earliest computers ever made, which means they are exactly the kind of thing our computer should be able to run. A Rust text adventure. Just like the classic ones, this one would have different biomes, weapons and enemies. I immediately laid out a Rust adaptation, and the ideas of what I wanted to implement just kept coming. At the end, I had a full diagram just to keep track of all the possible interactions. To make it look even more apart, I fired up Rust Edit, a tool that lets you build custom structures on your map. And I set out to model a computer. For reference, I looked at machines from the 70s and landed on the Commodore PET. Released in 1977, it was the first commercially available personal computer. Fitting given what we are building here. Starting with simple cubes, I shaped the whole, the monitor, the keyboard, scaling and adjusted until the silhouette started to feel right. The keyboard got special attention, with all symbols carved in every single key. Once done, I loaded it onto the server, walked up to it in-game, and honestly it turned out exactly how I imagined it. With the model in place, I repositioned the display and keyboard to sit exactly where they should be. And together they started to look like the real deal. And with that, every last piece was in place. Hundreds of hours of designing, debugging and rebuilding. I won't pretend it was exhausting, but I also genuinely enjoyed this. For this wouldn't be finished if I hadn't had fun solving all the problems nobody did before. Time to run the program. There it is, Rust, the text adventure. Press any key to start. We press a key and the next screen shows the first description. You spawn naked on a beach. A naked is nearby holding a rock. 2 options appear. Here's where we once again use the comparison logic from the calculator. The program checks which number you pressed and routes accordingly. This time we press 2 to go south. And there it is, now we are on some grassy plains. Where do we go from here? Well, Rust is open-ended, yet I needed a goal for my version. Therefore I made the goal to raid another base. Now it's just a matter of finding it. From the plains we can go west or east. Type 2 for west and we find ourselves in the forest. Here we can chop down a tree that gets us the item wood. And right there, a register flips in memory, tracking that item. The same system we built for Hangman, now acting as our inventory. What do we do with that wood? Well, usually you build a base with it in Rust, so let's do the same. Back at the plains we start building. The program checks in memory if we have the wood. Turns out we have some, and get ourselves a nice little base. Inside we find that we can craft. But for that we need a workbench, which means the next task is to find some scrap. East of the plains takes us to a road with barrels we can hit. And would you look at that, we found some scrap in them. Back at the base we make that workbench, which allows us to craft 3 different weapons, each stronger than the rock we currently hold. Chop down another tree and craft a bow at the workbench. On the road there was another route going south to explore. But this time when we enter the road, a hazmat pops out of nowhere. Without even knowing it, we got lucky the first time, cause every time we visit the road, there's a 50-50 chance the enemy shows up. This uses the same random logic from the fortune teller, now deciding whether we get ambushed. Well, now we have to fight them. We deal blow after blow to each other, but with the help of a bow, we are able to defeat him. We loot his body and find some metal fragments. Going south we come to the water treatment monument, where a green room awaits us. While this certainly holds good loot, it's a dead end for now. Going into the other direction beyond the forest, we find a desert and another base. This is the one we want to raid. But with no boom, we can't do that now. We wander onto mountains and finally find a gas station with gunshots from inside. When we enter the gas station, a full kit grabs the green card right in front of us. Given that we really need that one, we start a fight. But our bow is no match against him. He promptly sends us back to the spawn beach without any items, in classic Rust fashion. So to prepare for the fight, we build a base, get some metal fragments from the mountains, and craft a shotgun at the workbench. We return to the gas station. This time we have the upper hand. Grab the green card off the full kit's corpse, and with the green card we go back to the locked room. In here we find a C4. I just know where to use this one. We raid the other base by blowing up its walls, cause we want to let them know we are here to stay. Everything vanilla logic, no mods, just the game pushed to its absolute limits. After 2 years I can finally show the world what I have been seeing all along. And there is much more to come. This channel is your front row seat to the new era of electricity. The computer now is the most complex project I've made. Previously that title was held by a fully working Tetris game. To see how that came together, click this video now. A massive thanks to all my Patreons. Keep believing and stay splendid.